Okay, right, so let's continue with part 2 of the video. Geometric sequence has first term a and a common ratio r. We know the third term is 20 and the fifth term is 12.8. And it's a show that question. So third term being 20, so you know that the nth term of a geometric sequence is ar to the n minus 1. So you just need to reduce the term by 2. So the third term would be ar squared, and the fifth term would be ar to the 4, as stated down here. And we know that this is 20, and we know that this is 12.8. And the approach for arithmetic sequences should always be about finding the difference and subtraction. And for geometric sequences, you need to divide, because dividing these terms will get rid of a as a variable. So if you do the fifth term divided by the third term, you would end up with r squared is 12.8 over 20. So if you simplify that and square root, you will simply get r equals 0.8 for 1 mark. Part B, hence find the value of a. So when you know r is 0.8, you can plug that into here. And so a is 20 over 0.8 squared, which will be 31.25, I believe. Yep. That's another 2 marks. Now, given that the sum of the first n terms of the sequence is greater than 156, so since r is between -1 and 1, we can use scratch that. We're not summing to infinity, so we're summing to n. So s of n is a times 1 minus r to the n, all divided by 1 minus r. You want to find the sum of the first n terms. Now you know a is 31.25. You know r is 0.8. And you want to find the first term where this is greater than 156. So substitute your variables in. Substituting in, you would get 31.25 times 1 minus 0.8 to the n over 1 minus 0.8, multiplied by 0.2, divide by 31.25. Now, you cannot do the subtraction first when there's a power, so the easiest thing to do would be to take the negative 0.8n and write it on this side, pull that on the other side, and do 1 minus 624 over 625, which is 1 over 625. It's 0.8 to the n. Now, when you're trying to find a variable, you can, at this point, if you don't want to use logarithms, you can be justified in using trial and error, but logarithms is a little bit easier. So you take logs on both sides, and you get log of 1 over 625 is greater than log of 0.8 to the n. And as you know, with logarithms, we can take a power, write it as a coefficient, and then divide by the logarithm, which gives you n must be greater than 28.85. Given that n must be a whole number, therefore the smallest value of n where this is true is n equals 29. And that will get you 4 marks. Let's move on to question 8. Ooh, this is a tough question. There's a lot of students tend to find it difficult to find all of the answers to trig questions like this. First thing to note is part 1 must be in radians, part 2 must be in degrees, so you have to be comfortable in knowing which mode your calculator is in and how to switch between the two. We have an irregular range here, so it's from minus pi over 2 to pi, so we need to take that into account, and we have this expression. The first thing we should do is we should look at what our angle is, and our angle that we're finding the sine on is 3x plus 0.1. So we should find what the equivalent range is. So if you take this inequality and you want to write in the middle 3x plus 0.1, you need to multiply by 3 and add 0.1. So multiplying by 3 would be minus 3 pi over 2 plus 0.1 is less than 3x plus 0.1, which is less than 3 pi plus 0.1. Okay, right. Now let's head over to the expression and start rearranging. So we move the 2 on the other side, it becomes minus 2. Divided by 5, minus 2 over 5. Shift sign, and we'll find our primary solution. The first primary solution, which is minus 0.411. Pi minus this will give you our second primary solution. So we get minus 0.411 and 3.55. Our range is from minus 4.612 to 9.525. These are the numerical calculations for the expressions I wrote up here. So now, how do we find our solutions? We keep adding or subtracting 2 pi. So 2 pi is about 6.28. So add 6.28 to 0.411. Add 6 pi again. We're going to leave our range of 9.5. Add to 6.28 to 3.55. We'll go outside of the range. But if we subtract 2 pi, we'll get minus 2.73. So therefore, that gives us our 4 solutions within the given range. Rearrange by subtracting 0.1 from all of the answers, and then divide them all by 3 to get the 4 solutions. Okay. Let's have a look at part 2. Solve for 0 to 360 and the following equation. So when you've got a question like this, you've got tan, sine, and cos. So the first thing you want to do is you want to remove a degree of difficulty from the question by turning the tan into sine over cos. So now you only have 2 variables, sine theta and cos theta. So if you write tan theta as sine over cos, you will end up with sine squared over cos. And then you multiply by cos to get rid of the fractions, giving you 2 sine squared theta is 5 plus cos theta. Now we know that sine squared is 1 minus cos squared. And substituting that in means that we now only have cos theta as a variable. Putting everything on the same side and trying to keep the first one as positive gives you 3 cos squared theta plus 5 cos theta minus 2. You can say let cos theta equals x and solve the quadratic equation 3x squared plus 5x minus 2 equals 0 if you so desire, or you can work within the cos theta as well. So this gives you 3 cos theta minus 1 and cos theta plus 2. When are these 0? Well, for the first one, it's when cos theta is a third, or cos theta is minus 2. Now, we know that we know what a cos graph looks like, right? It starts up here and it goes up and down and up and down. It has a height of 1 and a greatest depth of minus 1. So minus 2 will have no solution. So this can be rejected, leaving you with simply 70.5. Are there any other solutions within the range? Well, cos is reflected around 180 degrees. So theta and 360 minus theta are equivalent solutions. So you have 70.5 and 289.5. Okay, here we go. Penultimate question. Right. A curve C with equation y equals x squared minus 4x plus 5. And a line L with equation y equals 2. The curve C intersects the y-axis at point D. Write down the coordinates of D. So we want the coordinates here, not just the value of what you think D is. So it's important you write this as a coordinate with an x and a y. So you know that the x is 0, And the y value is when x is 0. So if you look at this equation, when x equals 0, this is 0 and this is 0, leaving you with y equals 5. That's why it's a write down question. So 0, 5. Part B. The curve C intersects the line at points E and F as shown. Find the coordinates of E and F. Okay, so what we're saying here is when y equals 2, what is the value of x? So you substitute y equals 2 into our quadratic. As so, minus 2 from both sides, factorize, you get 1 and 3 as your two values of x. It's only asking for the values of x, not coordinates this time. Finally, the shaded figure is bounded, region 1 is bounded by C, L, and the y-axis. Region 2 is bounded by C and the given segments. Given that the area of R1 over the area of R2 is a constant k, use algebraic integration to find the exact value of k. Okay, so there are numerous ways you can approach this question. If we look at this, we can say, well, if this is 1 and this is 2, then this has an area of 2, and this has an area of 4. Okay. We can integrate C between 0 and 1 to get this area. And if we subtract 2 from it, it will give us R1. If we integrate L between 0 and 3, it will give us this area, the green area. And if we subtract this lower rectangle from it, of 6, it will give us the sum of R1 plus R2. So if we know what R1 is, and we know what R1 plus R2 is, we can find R2. And once you know R1 and R2, you can divide them to find K. That's the general thinking behind the question. So we integrate between 0 and 1, and we get 3 1/3. Definite integral between 0 and 1 gives 3 1/3. Subtract 2, that gives you area of R1 as 1 1/3. Now to find R2, actually there's an easier way. If you really wanted to find the area of R2, you could also remember what your 6th grade teacher taught you about finding the area of a triangle. You know that this is 3. You know that this is 3. So if there was a triangle with a base 3 and a height 3, its area is 3 times 3 over 2. 4.5. That would also work. A significantly easier approach. Okay. Oops. Okay. So if we know the sum of them is 4.5, and we know R1 is 1 1/3, subtract them. That gives you the area of R2, and then the ratio is the area of R1 divided by the area of R2, which comes out as 8 over 19. And here we go, last question. This one, it's quite straightforward. A student was asked to prove by exhaustion. So proof by exhaustion means consider all cases. If n is an integer, then 2n squared plus n plus 1 is not divisible by 3. So if an expression is not divisible by 3, all we need to show is that 3 consecutive numbers don't give a solution. The student's proof starts with the first number, 3k. So if 3k doesn't go into it, then we have to try the next number, which is 3k plus 1, and you go through the same step. And then you try the next number, which is 3k plus 2. So 3k plus 1, 3k plus 2, if they all do not divide or cannot be written as in the 3 times table, then it's not divisible by 3. So 3k plus 1, insert it into the expression, so it's 2 times 3k plus 1 squared plus 1 lot of 3k plus 1 plus 1. Factorizing and multiplying it all out, and that gives you this expression. So 3 goes into 18 and 3 goes into 15, so 3 goes into, well, there's 1 3 and 4, remainder 1. That means that this part of the expression is in the 3 times table. So if this is in the 3 times table and we add 1, we can no longer be in the 3 times table. So it's not divisible by 3. Let's try 3k plus 2. So 2 lots of 3k plus 2 squared plus 1 lot of 3k plus 2 plus 1. Multiply it all out. Bring your terms together. And do the same thing. How many 3's go into 18? How many 3's go into 27? How many 3 goes on to 11? So 3 lots of 6k squared plus 9k plus 3. But to get to 11, we need to leave 2. So that also is not a multiple of 3. This part is a multiple of 3. This part of the number is not. So therefore, 2n squared plus 2n plus 1 is not divisible by 3.